Hello, we're the Team 3, and today we're going to present our final proposal for the class of mechatronic design. What is our role as future mechatronic engineers? In 2015, the Sustainable Development Goals were declared by the United Nations with the objective to reach a sustainable development by the year 2013. But in even communities like the Instituto Tecnológico de Estudios Superiores de Monterrey, Campus Estado de México, people have grown accustomed of living in a polluted environment. In areas like in the Mexico City, where the CO2 generated by the transportation industry is the majority, a lack of sustainable alternatives of moving is a problem for the community. Here we present Scooty, an electric scooter for transporting efficiently, ecologically through the city with a net of charging stations that generate electricity in a sustainable manner.
Now we're going to talk about state-of-the-art and intellectual property. In terms of state-of-the-art, we know that sustainable cities and communities are a big necessity nowadays in terms of SDGs. And we're also having mega trends about how can we make sustainable transportation systems in both the private and the public sector. Our team found out that working for the public sector has lots of bureaucratic procedures, so it is easier to start with a private sector. And what better than our own institution and university, Tecnológico de Monterrey, Campus Estado de México, which has, by design, some transportation issues that can be solved. We researched for some of the patents that can help us in terms of scooter design, rain efficiency and protection, and also solar-powered energy, as well as some scientific articles related to RFID technology, energy and efficiency transportation, and how it interacts with the environment.
For the goals and objectives, it's important to mention that there are different risk factors in which they are involved, such as existence products already in the market, and technological issues according for the limitations of every society, and often the budget that every section has. And these risks are the main obstacle for the goals that we want to achieve, such as the continuous work for a sustainable society, as we saw in the last part, and the improvement of local infrastructure, first of all, in our own grow ecosystem. And if we have success with this, we want to create the idea to launch it, have a greater impact.
Well, the task list is a list of activities that we need to complete in order to fulfill the whole project. With this, we can make the Gantt chart that helps us visualize the time that every task needs to be completed. And with this, we can know the time that we will need to complete the whole project. Finally, the QFD is a tool that helps us to communicate with the user, and in this way to know the needs they will have regarding the product. With these detected needs, we can propose the engineering requirements that are needed to fulfill these needs. In our QFD, the chassis design, that is an engineering requirement, have a strong relationship with several customer needs, like that it needs to be lightweight, faster than walking speed, and durable.
And well, based on this information, we made the function tree and the black box. The function tree has different classifications for all the functions that have to be fulfilled by our project. The main one, as a transport student, is inside the SEM to transport the different people and students around the campus. And from then, we can have very different analysis of the subparts that are involved, like carrying the weight of the student, the comfortable alternatives for instead of walking, safety, sustainable, efficiency, and multiple charging locations, as well as the scooter tracking. And based on that, we made a black box that joins all the functions and sub-functions due to material flux, energy forces, and signal flux in order to make a logical diagram that can help us identify which are the parts, functions, and sub-functions that are interconnected in order to make the system to work correctly and to make a good design for our product.
At the start of the project, each member of the team had a proposal of how to solve the problem previously described. This is useful because it generates a diverse pool of ideas to create a proposal. But to ensure the ideas were able to merge and be focused, it was necessary to have constant communication inside the team, even when generating independent ideas. This ends with the final proposal, Scooty. This is the proposal for an on-campus scooter service. The idea is to have different charging stations in campus where the RFID technology serves us to identify the users that are using the scooter. Members of the campus are able to take a scooter from the solar power station and drive around the campus for a little charge. And after using the vehicle, the user are able to leave the scooter in one of the charging stations by scanning their ID, leaving another scooter ready for use.
Now we're going to talk about virtual prototype and physical prototype. The scooter is a simple design with all the functions and requirements specified in QFD and the function tree. It was decided that the main focus of the design will be the efficiency of the vehicle, so additional functions that don't link with that purpose were not considered. For this part of the project, we decided to design first the CAD of the scooter with the sensors and system that we investigated. The second CAD that we did was the stations of the scooters, and the team wants to adapt the places and stations that are in the campus with this infrastructure. Finally, for the physical prototype, we made a RFID in order to implement a security system and keep the use of the scooter only for the tech community with a card-based system.
Well, for the FMEA, we chose 6 components of trees of functions and we defined the severity, probability, and detection of what will happen if something went wrong in any of those components. With this, we can multiply the severity times probability and detection to get the risk priority number that, as the name says, numbers the priority of each risk in the components in which the higher number means that it was a higher property. In our case, the risk that has a higher property is if the chassis broke, and the risk with the minor property is if the connection between database and RFID detection system is lost.
As we know, every incoming improvement of the society must be tested and verified by multiple associations. For national standards, we have principally the NOM, which means Norma Oficial Mexicana, in which we can find NOM 68 and NOM 012 that are involved to the manufacturing and the way of how these vehicles will work and will make their job. And for also we have to include the implementation of electric designs for vehicles transportation. And this could include also the way of recharging of those vehicles and also the components of each one. Something to say is that these kind of documents are extremely detailed and very specific. And for the international standards, in case we will launch it internationally, we will face and work with the ISO, that means International Standardization Organization, in which we can find the ISO this 5474 that mainly includes the way of operating this kind of electric vehicles.
Well, finally, we have the result and conclusions. And the team worked for 5 weeks with different types of processes and methods to improve the first design that we have. And in this process, we had more information about the different methods to complement the design, more advice about how our design can be better, and important aspects that we need to consider to implement our mechatronic design in society, like aspects in relation about the design thinking. And this entire development of the project has allowed us to offer a functional prototype with mechatronic implements and always seeking to support the objectives objectives of sustainable development. Thank you so much.